Hello, good morning, everyone. Welcome back to learning more chemistry with me. So we had a really long lesson last day on talking about the alkyl groups and naming um, branch alkanes. So I'm hoping to have a shorter lesson today. So we'll get to that in a sec. To begin the class, I just want to talk to everybody. um, Make sure you guys from on Monday to Friday, make sure you check into the chemistry channel, right? On Teams, and make sure you like say open up a assignment, check out some of my posting, give it a like, so that way that's how the program can track your record your activity on Teams so that I can see it, so that I know you have spent some time on team like on just chemistry. Okay, so make sure you just click on some tabs and click on some channels and read through it, and open up an assignment and so on. And also to back that up, make sure you do the survey as well. So if I don't see your activities on team, then I'll go back to the survey and I double check, oh, you actually did the survey, so that's how I know you actually that you were present for the whole week from Monday to Friday. And usually I do the attendance by the end of Friday, like before 3 p.m. Okay, so and then I've been receiving some emails from some of you telling me like you guys, some of you were stressed with the workload as piling up on you and so on. So I want to start the day talking about different ways to distress. So I just browsed, the internet and just found this little, page that has 10 ways to de-stress yourself, release stress. Um, I want to, emphasize, we always, teachers been asking to ask you to, make sure you take care of yourself, right? Eat well, sleep well, okay? Um, don't, do exercise. And I find that, one way, to really to minimal to minimize stress in yourself is number 6. Do not procrastinate. Do not procrastinate. This is something that it's for some of you might be a little bit hard to do, like especially in this online environment where like some of you may not have enough discipline to just learn in front of the computer, like um, every day, and not get distracted by all the fun things on the internet or all the games that that you have on your computer. um, but this is something that I mean it's a learning experience for you, all of you, including myself as well. So learn to get more discipline to just focus, give yourself a schedule, every day, and say, from this hour to this hour I'm going to be working, and a lot some other time, some other hour during the day for playtime. Okay, so because if you procrastinate, if you let all your assignments, let all your homework get piled up, then that's where the stress comes in. That's why you feel so overwhelmed because you are so behind. Whereas if you like be on top of things, if you are dealing with what you need to be doing daily, then the stress level will go down for sure. Okay, so I encourage you guys to do not let your pile keep piling up. Try to catch up. Like, for example, this you have a long weekend coming up. You have a 4-day long weekend, right? So try to do all the catching up you can, and then after that, then you just deal with what comes to you on the daily basis. So, to like today on the day one, I give you a lesson, then you try to learn it right away. Usually my lessons are not too long, and the homework assignment I gave you is not too much, I think. So, try to pace yourself. Do, like just imagine, on a day one, you have 4 classes, then do a little bit of math, do a little bit of science, do a little bit of, like whatever courses you're taking. Okay. So, um, pace yourself, try to catch up, and eat well and sleep well. All right. So, And also another thing is I think from now on, instead of giving you guys lesson on day ones, I will just at most give at most 2 lessons per week. Okay, so I think that way you guys will hopefully be better managing your workload. Okay, but again, if you feel behind, if you feel overwhelmed, email me. If you can't finish an assignment on time, then let me know. Email me, let me know the situation. It's okay to hand in assignment late, but I do appreciate if you can let me know. Okay, so let's move on. If from last day you guys learned a lot of namings, so we're gonna continue that today. We're gonna move on to cycloalkane, and also something called alkyl halides. Okay, so get your notes ready. Okay, so that's you should have that ready when you begin this lesson. Okay, so we're going to start with talking about cycloalkanes. So we're still on alkanes. Alkanes, like what you learned from last 2 classes, alkane means single bonds between carbons. So cyclo is like a ring. Okay, so these are the cyclic hydrocarbons. So cyclic hydrocarbon means they are rings. Okay, now because an alkane is a straight chain, and when they form a ring, the head and tail of the chain, they are connected into a closed ring. So now the new formula for these rings becomes CnH2n. So they because they form a ring, they lost 2 hydrogen as a result. So just to recall from the straight chain, it's 2n plus 2. Okay, so we these are the alkanes. And because they are joined into a ring, they lost 2 hydrogens. So to name these hydro cycloalkanes, basically all you need to do is add the word cyclo before the name of alkanes. Okay, so we're going to start with, I'm going to show you, go back to the program that we were using last day. So MoView, I hope you guys like this program. I think it's pretty easy to use. So here on the left hand side, you see all these rings here. We start with this little triangle here. That means it's a 3 carbon ring. Okay, so we can add in so this is the skeletal look, right? And you can add in the hydrogen. This is the full um, structure for the cycloalkane. This is 3 carbon, so it's a propane, cyclopropane. And you can change that to a 3D structure. It looks like this, a little triangle, right? Okay. Um, so because the fact that a cyclopropane, you see the angle in this triangle, they're very small. Okay, so they're very constrained, they're very tight. So these cyclopropane is actually not stable at all. It's easily broken up into back to a straight chain. Okay, so this is a very unstable ring because the fact that the angle is very small. But if we go another one like this, um, 4 carbon ring, so that's a butane, cyclobutane, and now the angle has increased much more, so it becomes a 90-degree angle, so the angle is not as constrained, and so this one is a more stable ring. So this is a 4 carbon ring, and we can do so we have 5 carbon cyclopentane, and then cyclohexane is a very um, common one because it's a very stable ring, 6 carbon ring. Okay, so here we have the 3D structure, cyclohexane. Okay, 6 carbon. Okay, so all you need to know is know the names of these alkanes. So all you need to do is just put um, the word cyclo in front of it. Okay, so we're just gonna write down all the ones that we just saw. So start with cyclopropane. Propane means 3 carbon. So I'm going to do the full structure for this one. Okay, so you just draw a 3 carbon ring and add in the hydrogen. So you should know how to draw the full structure, and you should also know how to do the skeletal way. So the skeletal way is easy. You just basically draw a little triangle for that. Okay, so again, the angle here, it's like a very um, small angle here. So therefore, it's very tight. Okay, it will it can easily break into a straight chain. And the next one is cyclobutane, and for this one, I'm just going to draw a skeletal one. Okay, so each corner here represent one carbon, right? So it's a little square. Okay, so I'm going to ask you guys to do all the rest yourself, like draw cyclopentane. So that's 5 carbons. And then cyclohexane, 6 carbons. And cycloheptane, that's 7 carbons. Cyclohexane, pentane, and also cycloheptane, these three, the last three here, they are the more common types of rings that we see because they are very stable. Okay, so for the 5 carbon ring, you can draw something like this. Okay, so that's 5 carbons. And for hexane ring, cyclohexane, looks like this. Okay, so that's cycloheptane. Not very nice. Let me just draw it again. Okay, not the best drawing. Okay, I'm sure you guys can draw a bit. I don't like it. I'm sure you guys can do a better job than I do. Okay, here we go. All right. So now let's move on to namings. Okay, so now you know this how to draw the skeletal way, and you show the example I show you down below here. These are the condensed way, so you don't see the hydrogen sticking up, but they are like draw within with the carbon. Okay, so we're gonna learn how to start naming single substituted cyclohexane. Cycloalkane, so different types of ring size. Okay, so you are going to start with counting up how many carbons in the ring. Okay, so that's the like the parent chain. Okay, so that's the parent name for the ring, and then you're going to just take a look at the branch chain. So the single substituted means the branch. Okay, so here that means the branch. Just one branch. Okay, so like if you take a look at this example here, there's a branch here, there's a branch here, right? So that's what we did last day on the alkyl groups. Okay, so you should know that this one is the ethyl, right? And the one on the right, that's a propyl. Okay, so and then you just for this, because we only have one branch, you do not need to use number to indicate the attachment. Okay, so let's try the first one on the left hand side. Just count how many carbons there is. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this one has 8 carbons. So it's an octane. So it's a cyclooctane. Okay, so and then there's the ethyl group, and because there's only one ethyl group, you do not need to indicate the position. You just assume it's one, the first position. So you don't need to talk about it. You don't need to talk about it's one. Okay, so cyclo. Don't forget the cyclo. The word cyclo. Let's see, cyclooctane. I can spell this morning. I can draw. Oh, jeez. Okay. So ethyl, that's the branch, the side chain, and then the parent chain is cyclooctane. Okay, so all in one word, no dash, because there's no numbers. The second one is the same, pretty much the same. You just count how many carbons there are. This is a big ring. 7, 8, 9, 10, 10 carbons. So that's an octane, sorry, not octane, decane. So cyclodecane. And then we have the branch chain here. That's a propyl, 3 carbons, right? Propyl, cycloalkane. Okay, here we go. Okay, so that's it for naming, just having one branch chain. So now what about having multiple, having more than one branch chains? So in that case, you are going to um, so here's the rule. So same as before, you need to get the ring. What's the ring size, right? How many carbons in the ring? So that's the parent chain. And then for the first substituent, that means the first side chain, you're going to according to alphabetical order, you're going to assign that one as number 1. Okay, and then the remaining ones you're going to do either clockwise or counterclockwise, as to give the lower set of overall numbers for when you do the numbering. So I'll show you what I mean here. So for example, um, so for this one we have 2 side chains, right? So we're going to name the first one. So this is an ethyl and this is a methyl. So alphabetically we are going to give ethyl number 1. Okay, so this is position number 1 for ethyl. um, because E before M. Okay, so now we want to name, we're going to, you have a choice to go either clockwise or counterclockwise to give the number for the second branch chain methyl. So do you want to go clockwise or counterclockwise? So what the deciding factor is, you want to give methyl the smallest number. So that means for this one, you must go clockwise. Okay, so 2 and 3. So the position for this ring is 1 and 3. Okay, if you go counterclockwise, this methyl group would be a much bigger number. Okay, so that would be 4, 5, 6, 7, 8. So it's an 8 carbon ring, and ethyl is on the first position, methyl is on the 3 position. So here we go. Let's do the naming just like how we did it last class. So we have 1 dash ethyl dash. The numbers you have to separate it by a dash from a word. 3 dash methyl, and this ring is octane. Oh, not octane, but don't forget it's a cyclo. I forgot the C. Cycloalkane. Okay, so that's how you name a ring. So the parent name, you just put a cyclo in front, and then the side group, and you just use according to the alphabetical rule. Okay, E before M. And then you try to give it the smallest number, just like last class. Okay, so next one, let's try the next one. We have methyl. We have 2 side group of propyl. So M before P, right? So we're going to give methyl our group number 1. Okay, so again, now you're going to decide, should you go clockwise or counterclockwise to give the other side group the smallest number. Give you a second to think about. You can pause it, think about it. So the answer is you need to go for this one counterclockwise. So 2, 3. The position is 3, 4. Oh, my pen is weird. Acting weird. 4 and 5. 6, 7, 8, 9, 10. Okay, so that's how you're gonna name the numbers. Now, if you're not convinced, you can think about, okay, if you go name this 1, and if you go clockwise, that will be 2, 3, 4, 5, 6, 7. So the next the number that reached the next side chain would be 7. Okay, so it will be 1, 7 and 8, 1, 7, 9. So instead of the blue one, which is 1, 3, and 5, that would be a smaller number. Okay, so that means the red one is incorrect. So let's finish naming this giant ring. You guys can pause for a second and do it yourself, okay? And then come back and check the answer. So the answer is 1 dash methyl dash 3 comma 3 5 3 comma 5 because you have two propyl. Okay, so when you have two propyl, you just go dipropyl, and then the ring is cycloalkane. Okay, so super long name. Okay, I hope you guys did it right. And now I want you guys to again pause the video and try to draw draw the next two. Okay, so practice yourself. I gave you the name here, and I want you to pause the video and draw these two rings. You can draw the skeletal one. So for example, this one cyclohexane, you just draw a skeletal. You can draw the long one or the condensed one, but I encourage you guys just make it simple. Just draw the skeletal one like this. Okay, so I'm going to pause it and finish drawing these two, and you guys check the answers. Okay. Okay, so hope you guys had a chance to draw it yourself. I'm going to show you two different ways to draw this. I'm going to start with this is the answer for the skeletal way. So I have here on the left-hand side a 6-carbon ring, and then the ethyl group, number 1, this is my number 1 ethyl, and this is 2 carbon. So that's ethyl. You don't have to draw the red dot. I'm just showing you that that's an ethyl. And then this one, number 2, methyl, and that's my methyl group right here with 1 carbon, CH3. Okay, so that's one way of drawing it. And then the methyl group could be on the right hand side, on the left hand side as well. Doesn't matter because you can reverse it. This is a 3D model. And then this one is a 5-carbon ring, right? So 1, 2, 3, 4, oopsie, 4, 5, right? And then you have the two um, methyl groups sticking out like this. Okay, so that's how you draw the skeletal way. But I'm going to show you how to draw I'm going to draw the condensed way. Okay, so here I have drawn the cyclohexane on the left. So I'm going to add in the ethyl group. So CH2, CH3. And then I'm going to add in number 2, CH3. That's the methyl, 2-methyl. Okay, so now you're not done. You're almost done, but you need to fill in all the hydrogen for carbon. So you need 1 hydrogen here, right? Because carbon has 4 bonds, and this carbon has 2 already, so it needs 2 hydrogens. 2 hydrogens. The hydrogen can be drawn on the left-hand side or right-hand side, doesn't matter. CH2, basically. CH2, and then this one needs 1 hydrogen. Okay, so again, you can pause it here and try to draw this one if you didn't draw it right. Okay, draw the cycloheptane 5-carbon ring, and then all you need to do is add in 2 methyl groups. So 1 dimethyl. So CH3, that's 1 methyl, CH3, that's another methyl. Okay, and then now all you need to do is add in the rest of the hydrogens. CH2, 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 CH2. Okay, so if you're having trouble with this, go to the program, that 3D program, the Moville, and draw this. Try to draw this diagram, the skeletal diagram I drew here, and you will be able to see this ring. Okay, so moving forward, I promise to make this lesson short, but it's not as short as I wish, but let's go. Well, one more page to go. This one hopefully will be a little bit shorter. Alkyl halides. Okay, it's this weird word. Alkyl means branch chain with, it just means branch chains with hydrocarbons. Now, the word halide comes from the word halogens. Okay, so basically, alkyl halides means are hydrocarbons with a halogen attached. Okay, so we call what are halogens? Halogens are the one family, right, on the right hand side, and they are these guys: fluorine, chlorine, bromine, and iodine. Now, just going to finish this table here. When you have halogens attached to an alkyl, alkane chain, you're going to change the name slightly. Okay, so fluorine, you're going to change it to the name fluoro. Chlorine, you're going to change it to chloro. And bromine, you are going to change it to, sure you get the hang of it, bromo. And iodine, iodo. That's right. Okay, so here are some of the rules. So name the alkyl halide the same way as alkyl group. So all the rules are, very repetitive. The endings, we just learned the ending, fluoro, bromo. Use number to indicate the position of the attachment. And if there are more than one, use di, tri, and tetra, and so on. And if there are alkyl group and halo group, halogens, that you need to use alphabetical order, okay? And always try to give it the lowest set of number, just like before, okay? So everything is quite similar. Now, let's start with the first one. This one, you have CH3, Cl. So I'm just going to draw this one in a full structure. So this is one carbon, right? So this is a methane. So methane, you have, for this diagram, you have 3 hydrogen attached to it, but one hydrogen is substituted by one chlorine. Okay, so how do we name this? So this is an exception. You do not need a number because there's only one possibility of carbon where the chlorine group can attach to. Okay, so for this one, the parent name is methane, right? And you have a side chain, the alkyl halide chloro group attached to it. So we're going to call this chloromethane. That's it. Okay, so normally if CH4 it's methane, but now you have a chloro group attached to it, so it's called chloromethane. Okay, next one, you have 3 carbons here, right? So 3 carbons, and you have one bromine attached to it. So 3 carbon, that's a propane, but you have one bromo attached to the propane. And for this one, you must use a number, okay? And for this one, this bromine is attached to the number 1 carbon, okay? So you try to give it the lowest number. So in this case, it's number 1, okay? So for this guy, it will be named as, try it yourself if you want to pause it, 1 dash bromo, and it's a propane. Okay, and now you may be asking me like, oh, why do I need the 1 like the previous one? The chloro one doesn't need the 1. I'm going to show you why by giving you a different molecule. So CH3, CH3. So now instead of the bromo group, the bromine on the side, I could put the bromine on the second carbon like this. Okay, so now this one, try to name this guy, try to give it the smallest number, 1, 2, and 3. So you guessed it, this is 2 bromopropane. Okay, so you can tell having the number is so important. Otherwise, like people, when you like giving this name, people don't know where the bromine is located. Okay, so the next one, number 3, is an interesting one. All the hydrogens got replaced by chlorine and fluorine. Okay, so I'll draw you the full structure for this one. And you guys, once you finish drawing this, pause a moment and try to name this one yourself. Okay, so the parent chain here is, oopsie, it's ethane, right? So 2 carbon, it's ethane. But there's no more hydrogens, and you have got all these halogens attached to it, and you have to indicate where they all are and with the proper location. Okay, so alphabetically, we are going to name the carbon first. I mean, name the chlorine first. Okay, so I'm going to name this one carbon 1, and this one is carbon 2. Okay, so again, pause a moment and see if you can figure out the name for this. Now, this is what this one is a tricky one. This one you have three chlorine attached to the first carbon. So there are three. One, oh, oopsie, no, not 1, 2, 3. They are one comma three chloro groups. And when you have three chloros, it's trichloro. So it's 111 trichloro dash. I'm just gonna 2, 2, 2. Just gonna write it on the bottom here. Tri. That's a dash. Okay. Fluoro. And the parent chain is ethane. So this one is a little interesting when because you have to indicate there are three chloro group on the first carbon, okay? And then there are three fluoro group on the second carbon, and the parent chain is ethane, okay? So again, this is a dash. I'm just running out of space if I to go horizontally, okay? So you have to indicate all these numbers. Otherwise, when you draw this, you could have the chloro and fluoro reverse. But for this particular molecule, all the chloros are on first carbon, all the fluoros are on the second carbon, okay? And you cannot mix them up, okay? So that's the name of example 3. So I'm going to write down the examples for the next 3 examples. I'm going to pause it and then I'm going to you guys can copy it down, and then actually I'm just going to write it now, and then you guys can pause it and try to name it yourself. Okay, so here we go. CH2, CH2, CH, CH2, CH, CH3. And I'm going to add some halogens here and here. Okay, so that's example 4. Example 5, it's a ring, 5 carbon ring, F here, CH3 here. Okay, and then you know what? I'm going to erase this now because I'm kind of running out of space. So you guys can go back if you need to copy the name. Example 6, CH3. Add 2 chloro group here. Okay, so I'm going to pause here. I want you guys to name example 4, 5, and 6. And also I want you to try drawing the 2 compounds for example 6 and 7. Okay, and then we will come back. You just pause and then come back and check the answers with me. Okay, and that's pretty much the end of the video for today. Okay, so for the first one, example 4, you are going to try to give it the lowest numbers, right? So to name the carbons, you have to go from left to right. So give the first iodide number 1. Okay, so just 1 to 5 for 1 and 5 for the 2 iodide iodo groups, and then the bromine. The bromine here is on group 3. Okay, so to name this, you got to go alphabetically. B before I. So 3 bromo, 1 5 diiodo. Okay, because there are 2 iodine groups, and then the parent chain is hexane. Okay, I hope you got this right. Don't forget alphabetically and try to give it the lowest number. Now for the rank here, I'm giving fluorine number 1 because fluorine is before M methyl. So alphabetically, I'm giving fluorine number 1. So I'm going to name this one fluoro. Got the O. 1 fluoro, 2 methyl. And then the ring, it's cyclo. This should be in one word, but I'm running out of space. cyclo, not hexane, but this is a pentane. Pentane. Okay, so 1-fluoro-2-methyl cyclopentane. And I want to do this number 6 with you. So number 6, you have to try to figure out the longest parent chain first, and realizing that also you have some alkyl halides. Okay, so alkyl halides here you have two chlorals. Now normally you try to go different ways to get the longest chain. So this is one way, getting the longest chain. And but some of you may be thinking, oh, what about I can go from here and go right. Okay, so that way I will have 6 carbons straight. Okay, but for this particular one you can't do this because the chloral group, the parent chain must contain the chloral group. Okay, so for this one you must have the parent chain like this, 5 carbons, and then the side chains are 2 chloral groups, and then this one is a propyl. Okay, and then you have to decide, okay, I'm going to go from left to right. 1, 2, 3, 4, 5. So that is the lowest numbering, right? And then start numbering them. Okay, so you have 2 chorals. So 2, comma 2 dash dichoral dash 3, the position of the propyl group, 3 dash propyl. And then the parent chain is pentane. Okay, here we go. So I hope you guys are getting the hang of this. It's very logical and systematic. And for drawing, let me just draw the first one with you guys quickly, so you guys can, if you're not with me and you don't know how to do it, then follow me. Okay, so start with the parent group pentane. And then I usually go left to right for the numbering. 5 carbons. So 2 bromo. So add 2 bromo. Bromo on position 2. And 2 chloro. So I'm going to draw on the bottom. Just erase the 2. This is chloro, right? And then 3 ethyl. CH2, CH3. Okay, make sure the 2 before 3, that's the ethyl group. And then 3, 4 difluoro. That means there are 2 fluoro groups. So you see the numberings are so important. If you don't give the number, then I would have no idea where to put those halogens or alkyl groups. So 3, 4, I'm going to put the fluorine here as well. 3, 4 difluoropentane. Okay, so almost done, except you need to fill in the extra hydrogens. So the end here, there's 3, the CH3, CH3. The middle ones, this one is full, this one is full, this one missing one hydrogen. You can put it on the top, or you got just put it on between it is fine. Okay, like this. Okay, so pause the next one, and I will draw the next one for you to before, and then we will end the video. So that's the answer for number 7. I hope you guys got it right. For me, for this one, I decided to go clockwise. I decided to give this one position 1 and 2 and 3 and 4, like this, 5 and 6. So it's 1, 2, diiodol, and then 4, methyl. Okay, so I drew the skeletal one for the ring, and then the other one I just draw the condensed one. Okay, so homework is on OneNote. I hope you guys is getting the hang of it. It's kind of, it was at first it's complicated, but I'm sure you guys now understand why the numbers are important. But if you draw it the reverse way, right, the number gives you the position of all the side groups. Okay, so work hard, guys. Have a very nice weekend. I will see you guys. I'll talk to you guys next week. Okay, bye.